So, guys, you can see my screen.
Yes, Rahil, we can see your screen.
All right, Janet. Thanks for confirmation.
Alright.
Good morning, guys. My name is Rahil, and I'm working as a pre-sales consultant at Redington Gulf, and I work on AWS. I have extensive AWS experience. I've worked on Microsoft Workload. I've been part of DevOps operation also. So, in today's webinar, we are going to discuss about Microsoft Workload on AWS. So, let's get started. So with AWS, the AWS launches a plethora of services related to Microsoft every year. So the journey started back in 2005 and it keeps on going. So there are huge amount of services which is available specifically for Microsoft workload. And in this slide, you can see the 11 years of innovation for Microsoft on AWS. So services marked in blue is for Windows Server and Amazon EC2. In orange, you can see services related to SQL Server. Yellow depicts .NET related services, and green depicts application modernization, specifically for Windows. So with Windows Server on EC2, you can see services related to Session Manager, Windows Server 1803, Active Directory, Cross VPC endpoint, License Manager, and tons of other services. When it comes to SQL Server, you can see support for, let's say, SQL 2017 AMI on Ubuntu Linux, right? So you can run SQL Server on Linux, and it's supported on AWS platform. You have SQL Server 2008 upgrade service, which allows you to directly upgrade your SQL Server 2008 instances, and many more. Similarly, you have services for .NET. So .NET Core, let's say, .NET Core 2.1 support with an integration with Lambda and X-ray integration for enhanced monitoring. You have .NET Developer Help Services. You have CloudWatch App Insight for .NET application. The bottom line is AWS launches every year. They launch a large number of services specifically for Microsoft workloads, and we'll see that in the upcoming slide. So here are some statistics which says almost two-thirds of the Windows instances running on public cloud runs on AWS. So we can see even though Azure is a native platform for Microsoft Windows, it's a platform owned by Microsoft, but still the customer prefer to run Microsoft workload on AWS. The reason is, of course, platform stability and the ecosystem of services available for Microsoft workload, right? It, at the bottom, you can see a link. You can refer to this link and uh, you can check the case study. The research, so IDC every year they conduct research on various cloud platform, and this is their finding. Now we'll talk about connectivity concepts. So if you have Microsoft workload deployed in AWS in multi-AZ architecture in public-private subnet, which is very standard. So you'll have a two-tier application. There will be public-facing instances, and you have databases and middleware in your private subnet. How would you connect to those resources? The answer is through either a site-to-site VPN or through Direct Connect Gateway. So this can connect to your on-premise resources, and you have end-to-end connectivity established for the resources hosted in AWS. Now, at times, we have seen that when you have a multi-regional architecture, where you have multiple regions, where you're using multiple AWS region, the connectivity can be a challenge. So you have resources hosted, let's say in Ireland region, you have resources in Middle East, Bahrain region, and in many other regions. So you require those many connections, those many VPN connections, and it can be difficult to manage at times. especially when you have, let's say, 5 VPC or 8 VPCs in each region. It gets really difficult to manage. So what AWS did, they come up with a service called Transit Gateway. So in Transit Gateway, you can terminate all your connections, all your Direct Connect gateway, all your VPC gateway connections, your VPN connections, VPC peering connections. Everything can be terminated at Transit Gateway. And Transit Gateway knows how to route traffic to the backend AWS services. So the only point of connection in your case would be Transit Gateway, and it simplifies a lot of connectivity requirement for many of the end customer. So with AWS, they always recommend to go with a multi-account approach, where you have dedicated account for services. So you will have an organization master account through which you manage your compliance requirement, through which you manage your payments for all the other accounts. And then you have core accounts basically for security, for log archive, for networking, and other shared services. Then, depending upon your team structure, you can have accounts, AWS account for development team, you can have AWS account for production, operations, pre-productions, right? So you can logically create the hierarchy, and the idea is by creating those separate account, I provide restrictions so that development account, let's say, cannot see resources in production account, and I have full segregation. That's the whole idea. And all these accounts basically you can enable connectivity using VPC peering if required, but you'll only allow certain traffic, not whole traffic, right? And when it comes to connectivity to your on-prem data center, you will have VPN connectivity or direct connect connectivity to your network account, right? So what's the challenge here? So the challenge is it can be really hard to manage multiple accounts. Why? Because you might have different set of policy requirement for each and every account. For example, you want to give full control to developers in development account, but you don't want to give full access to the developer in production account. You may want to give limited set of access. You want to control, you may have different authentication policies for each account, right? So it can be hard to manage multiple accounts. So what AWS did, they introduced a service called Control Tower, and what it does, it makes sure that AWS best practices, AWS policies are enforced across each and every accounts, and you have pre-packaged guardrails to enforce policies for any kind of violation, or it can even detect violations. You can also automatically set up AWS account. So if you set up a control tower, you have options to automatically create AWS account for you. So it can launch an automated landing zone with best practices blueprints. So you have a blueprint, and you can use those blueprint to create your AWS account structure. When it comes to visibility, you have dashboard for oversight. You have continuous visibility into workload compliance and control. So you don't have to log into multiple AWS account and see what is happening. You can centrally uh, visualize your compliance status. So what are the key features and benefit of control towers? So when it comes to account setup, you can automate your account setup in a secure and scalable configuration through landing zone. You can have multiple account management using organizations. So I hope you know about organizations. So AWS organization allows us to group multiple AWS account together, and you can enforce policies for centralized management. So you'll have in Control Tower, you'll also have account provisioning wizard through which you can automatically provision your AWS account. You can also enable centralized logging and multi-account configuration consistency. So that's for the account setup. Now, what are the guardrails? So the guardrail could be anything. It can be based on the AWS best practices, Or if you have a customized tailored requirement for your AWS account structure, you can enforce those guardrails too. So so for example, multi account preventive and detective guardrails can be enabled. You can create rules in plain English. It's very easy to configure those rules. It's very simple and easy to use dashboard and notification. So you have a very easy dashboard, so you can visualize everything, and you can set up alerts for any kind of a violation, right? So control tower really simplified the multiple account management, and it makes our life very easy. Now we'll talk about Active Directory services. So for any kind of Microsoft workload, Active Directory is the core. So how would you deploy your Active Directory on AWS, or what are the options available in AWS for Active Directory setup? So here we have multiple options. One is AD connector. So using AD connector, you can connect Windows on Amazon EC2 and AWS apps to on-prem AD. So if you want to use your on-premises Active Directory and you do not want to deploy new AD in AWS, you can very well use AD connector. So it proxies all domain controller traffic to your on-prem AD. Second option is to have your own managed Active Directory. So AWS also offer services for managed Active Directory, where you can select the namespace, where you can select your domain name, and it will deploy a new forest for you. So it will be your own managed Active Directory, and it's a full-fledged Microsoft Active Directory for enterprises. It's not a lightweight directory service; it's a full-fledged Active Directory service. The third option, where let's say if you need a lot of customization, if you need a custom installation of Active Directory, you can install Active Directory on Amazon EC2. So it will be your self-managed Active Directory on AWS. It will not be a managed AD, but you manage the Active Directory, which is running on AWS. So with managed AD, many of the things like OS patching, Active Directory, schema backups, and everything can be taken care by AWS. But with self-managed Active Directory, you are responsible for managing the schema, operating system patching, and rolling out any sort of updates. So basically, these are the three options. In addition, the fourth option is to run a lightweight Active Directory, which is not Microsoft AD, but it's a lightweight AD. It's supported on Samba protocol, which is predominantly for Linux. Now we'll check the AWS architecture for different scenarios. The first scenario is with AD connector. So how it looks. So on your left hand side, you will have resources, Windows apps on EC2 instances. Let's say it's a .NET application, and it has a requirement to connect to Active Directory. So what you'll do, you will have an Active Directory connector running in AWS, and this will be able to connect to your on-premises Active Directory. And the on-premise Active Directory, as you can see here, it can also connect to your Windows application running on-prem. And if you have Azure AD for Office 365, you can use Azure AD Connect to connect to your Office 365 and Azure AD for single sign-on, basically. So in this case, we do not have an Active Directory or a domain controller deployed in AWS infrastructure, but we are proxying all the traffic to on-prem AD using AD connector. And as you can see, if you have Azure AD Connect in your on-premises, it can sync with your actual Azure AD deployed in Azure. So you do have that option, and you will have consistent directory structure. Now we'll look at the other case where you'll have a managed Active Directory deployed on AWS. So if you have an AWS managed AD, your resources in AWS can connect to those managed Active Directory. And let's say if you have FSX for Windows file server, it can also use managed Active Directory to for user authentication basically. So any of the operation that you will do with Active Directory, if you have AAA authentication requirement, you can use AWS Managed AD, and your AWS resources deployed inside your VPC or in a region can use Managed Active Directory for user authentication. It's a full-fledged Active Directory, but since it's a managed service, so you will not be responsible for OS patching and other related stuff. Now we'll talk about hybrid Active Directory architecture with managed AD. So let's say if you have multiple Active Directory, multiple forest, what would be my, how would I connect? So this diagram actually shows the connection strategy if you have multiple Active Directory forest. So on the left hand side, you can see your AWS resources, your Windows app running on Amazon EC2, and your SQL Server RDS instance probably. Yeah, and it does have some Active Directory connection requirements, so it can connect to AWS Managed AD for user authentication, authorization, uh, and your managed Active Directory can also connect to your on-premises Active Directory forest, and it can be one-way trust or it can be two-way trust also. Generally, for security, many people prefer one-way trust. So Active Directory AWS Managed AD can have one-way trust to your on-premises Active Directory. And the remaining structure would be the same, where you have Azure AD Connect for Office 365, and you're using Azure AD for basically Microsoft related workload running on Microsoft Cloud. Right. So the difference here is you have AWS Managed Active Directory also, and you have on-premises Active Directory also, which is a different forest, and you will enable connectivity between these forests through a one-way trust. It's Active Directory one-way trust. Right. Now we'll look into options for deploying SQL Server on AWS. What options we have if we want to use SQL Server on AWS? Basically, we have two options. One is to use Amazon RDS for SQL Server, and the other one is to deploy SQL Server on Amazon EC2. So in this case, in the second case, the SQL Server will run as on a virtual machine. Let's look into RDS for SQL Server. So with RDS, as you can see, it's a managed service. So everything related to power, operating system installation, maintenance, OS patching, DBMS installation, DBMS patching, database backup, high availability if needed, scaling, everything is taken care by AWS. It's an AWS managed service. So with RDS, you will get a DNS endpoint. Using that endpoint, you can connect to the database, and of course, you will have a connection string and username and password to connect to the database. So it's in a nutshell, it's a managed service. So you are no longer required to manage OS patching, right? Database backups, DBMS patching, nothing is required. You'll just get an endpoint, and you can straight away connect to that, connect your application with SQL Server. So here the focus is on a business value task, not on management. So you want to offload management to AWS, but you want to focus more on your business related activities, right? A- And in this case, you do not need any in-house database expertise. So because everything would be taken care by AWS, starting from installation to management to patching, you're covered by AWS managed services. But at times, you need a very customized installation of SQL Server. You want to customize how to install SQL Server. For example, you want to enable certain features, or you want to give a certain selective inputs to your SQL Server installation. In that case, you can also install SQL Server on an Amazon EC2 instance. In this case, you are required to manage operating system patching. You're required for database management system installation maintenance. You're also required for to manage DBMS patching. Database backup is again our responsibility, so we should have tools in place to take the database backup. High availability, if we have to configure, it's again on us to use SQL Server native services like always on to configure high availability, and scaling also will be on us. If you have to scale your SQL Server instance, we have to do it using some script or manual scaling, right? So the idea here is when you need more control over your database instance, when you need custom installation, or when you need to enable certain reporting features of SQL Server, you may consider installing SQL Server on Amazon EC2, right? When you have a requirement for clustering, SQL Server clustering, and when you have specific requirement to, let's say, uh, configure SQL Server parameter, you will go with SQL Server installation on Amazon EC2 instance. But most of the time, you'll be fine with RDS instance, and I would highly advise to use RDS instance because it really takes the management overhead from us, and we can focus on our core business value tasks, right? So we talked about RDS. Now let's see Amazon RDS multi-AZ deployment. So with multi-AZ deployment, I can get high availability. So what happens is synchronous volume replication within AZ and synchronous data replication happens across AZ. So there is a synchronous replication which happens between a master node and the secondary node. Recovery time is typically close to 1 minute, or sometimes even less than 1 minute. Under the hood, if multi-AZ is enabled for SQL Server Enterprise Edition, it will use always on feature. Uh, if you're using SQL Server Standard Edition, then under the hood, database mirroring service will be used to provide you high availability. And failover is triggered by the SQL Server itself. So as you can see in the slide, you have master node in availability zone 1 and you have standby node in availability zone 2. And let's say it is a SQL Server Enterprise Edition, so you will have always on feature uh, which will replicate your master and secondary node, and your volumes will have a volume replica, and everything will be replicated to the secondary zone, right? Uh, you will have a database, you'll have a endpoint basically through which your application can connect to the SQL Server, and it always connect to master node. If let's say failover is not triggered, then it will always connect to the master node, right? Let's talk about failover scenario. So in case of failover, what happens? Uh, Amazon RDS endpoint will detect a failover. So if let's say your uh, a failover request is triggered by Amazon RDS endpoint. So what happens? Secondary node will be checked, address apply depth will happen, and then promote secondary nodes will be promoted to primary. Change in DNS endpoint will happen, and secondary node will become master. The roles will be switched in this case, and this, by the way, happens automatically, so you don't need to manage the whole process. So changing endpoint, promoting master, promoting secondary node to master happens automatically, so we don't have to manage this, and we will not notice also at times. So when AWS initiates a patching activity, it initiates patching on the secondary node. When secondary node is patched, it will be promoted to master, and then master would become secondary. Then patching will happen on the secondary node, and the roles will be switched in this case. So this is just to explain, but you will not even notice what is happening when you use RDS services. The bottom line is the failover process would be automatic, and you don't have to initiate any kind of triggers, or you don't have to monitor those activities. It will happen seamlessly. Now, if you're a .NET developer and you want to know more about, and you want to interact with the AWS resources, you want to know more about AWS offered services for Microsoft Workload, you have tons of tools and tons of services. So some of the tools which you can use for developing your .NET application is AWS SDK for .NET, AWS toolkit for Visual Studio. You do have a toolkit and it integrates with your Visual Studio platform. And using that toolkit, you can use native C# syntax to manage and provision AWS resources. You have AWS tools for PowerShell, which I really like, because using the PowerShell native syntax and PowerShell native command, you can manage your AWS resources. So AWS tools for PowerShell is also available. AWS tool for Microsoft Visual Studio Team Services. If you have Visual Studio Team subscription, you can use AWS tool for Microsoft Visual Studio Team Services. And using all those tools, you can manage and control AWS resources in your AWS account. So let's talk about hosting option. If you have a .NET application, what are the available hosting options? So one option is, as you know, hosting everything on a virtual machine. So you have a .NET, let's say, two-tier application. So you will have fleet of instance in web tier and fleet of instances in database tier. And uh, the application can be deployed on virtual machines. The second option to host your .NET application is on containers. Yes, so Windows containers are actually supported on AWS, and you can use container services, Amazon ECS, to deploy your uh, .NET application on Windows containers. So that's another option. So basically, this will be replatforming. So if you have an application running on on-prem virtual machine, you have to replatform it to run on container. The third hosting option is to go serverless. So you can have your application converted into microservices, and each microservice can be triggered using a Lambda function. So as you know, Lambda function, it does support .NET framework and .NET language. So if you have C# code, you can run it using Lambda function. So serverless would be a refactor approach where you are actually changing the whole architecture of the application. So it requires an effort, but if you manage to use or if you manage to leverage serverless architecture, it will give you a lot of saving. We'll talk about application modernization and what is the optimization pathway. So uh, when we say application modernization, will be specific to .NET application in this case. So in the current in an on-premise state or in current state, the application will run on .NET framework, and you'll have a backend database SQL Server, which can run on-prem or on any cloud, public cloud, let's say AWS. So your modernization pathway would be to on the application stack. Basically, you can run .NET Core on Linux, and you can now leverage Linux containers for for .NET Core application, or you can go completely serverless using Lambda. For database modernization, you can run SQL Server on Linux now, and you can integrate your database with Aurora also, or you can actually convert your SQL Server into Aurora. So it's again a managed service. The advantage is you can with Aurora, you can go with complete serverless approach, where you have Aurora serverless. You don't have to guess the capacity. The based on number of transactions, the database engine can scale automatically. So modernizing Windows workload increases cloud maturity, lowers cost, and enables new innovation capacity. So if you run .NET Core on Linux, you have access to the whole Linux library, right? And you can customize your application, and you can use those library to tailor your application. Now, we discuss a lot of we had a lot of discussion related to serverless. There are some myths related to serverless architecture, but let's try to understand what are the core advantage or why people are thinking about serverless architecture when they talk about application modernization. Well, the advantage is you'll have automatic scaling when you go with serverless, so you don't have to guess the capacity. whenever you need, you can scale your application. You never have to pay for idle time. So if you're not using any resources on AWS, you don't have to pay for it. So no infrastructure provisioning is required. So serverless means you don't have to manage underlying AWS infrastructure. You don't have to manage virtual machines and anything. It's basically running functions. So whenever there is a trigger, so the functions will be executed. If there is no trigger, then functions will not be executed. So there is no infrastructure component in the serverless architecture. And of course it's highly available and fault tolerant. So uh, that's the serverless architecture. Some of the serverless services would be Lambda, which allows you to run functions on demand, AWS Fargate, which allows you to run containers on AWS without managing the underlying infrastructure. You don't have to manage the EC2 infrastructure for running containers. Amazon S3, which is very popular for object storage. You have Amazon DynamoDB if you want to use NoSQL. DynamoDB would be a good choice for you because it's a managed service, and again, it scales on demand, so you don't have to guess the capacity. You have Amazon Aurora Serverless, which is compatible with MySQL and Postgres. So in Aurora Serverless also, you don't have to guess the capacity; it will scale automatically. Cognito for managing user authentication, user pool. You have Amazon Kinesis. Kinesis again will allows you to stream data into your AWS infrastructure, SNS for notification, SQS for managing queue, and API gateway to front end your application. Right. So these are the serverless offerings from AWS. Now we'll look into pricing in this slide, and we'll just come up with a scenario where let's say you have 16,000 requests a day, which takes around 200 milliseconds of execution times. So your execution times per day is close to 3.2 million millisecond a day. So if you have virtual machines running and serving the application traffic on C3 large instance in a highly available manner, it will roughly cost you $2.97 a day. But in serverless architecture, when because here in this case it's based on request, and you are not paying for the underlying infrastructure, you're not managing the virtual machine, so it's all on demand. So in this case, your cost can be as low as $0.05 a day. So that's why people are opting for re-architecture or application re-architecture approach, right? Uh, we will also discuss about migration scenarios. So if you have a traditional application and you want to migrate those application to AWS, you have tons of services provided by AWS, including Cloud Endure, which does block level replication. You have SMS, which can migrate your virtual machine to AWS. So it's basically for rehosting. Using those services, you can actually migrate the whole virtual machine infrastructure to AWS. And if you have a backend SQL Server, you can use Database Migration Service or DMS to migrate your SQL Server to AWS. Uh, the second option could be backup and restore. If you do not have, you know, database of huge volumes, and if the database size is not changing every second, you can very well do a backup and restore and then do an incremental sync, and you'll be fine. Right. So for migration, also AWS offers a lot of services, and of course you can use third-party tools if you have. So there's no stopping for third-party tools. Now we'll try to understand about Microsoft workload operations. We'll look at the architecture perspective. Now we will look from the operations perspective, right? So when you have a Microsoft workload running on AWS, the operations cycle starts from infrastructure provisioning. Then you have a configuration management requirement. You are also required to monitor the performance of your workload, right? You have certain governance requirement and certain compliance requirement, and then you have to optimize your resources. So there is a life cycle around operations when, especially for Microsoft Workload. And we will look into these cycles and we'll revisit this slide in the end just to see how we can address all those areas. So let's start with infrastructure provisioning. So what are the steps to build an environment? So this is a traditional Microsoft Workload architecture. So we'll have IaaS web tier. You may have IaaS app pools uh, in the private subnet, and you have a backend database which is running on Microsoft SQL Server. For authentication, you may have Active Directory services running in multiple availability zone for high availability. Now, this architecture is good. So we have high availability, we have different tiers for application, and we have database tier as well. So everything is highly available. But the challenge here is it's non-repeatable. So if you have to follow the same architecture for another set of application, you have to rebuild the whole thing from the scratch. You may have some human errors. So for example, you may leave SQL Server port open for anywhere, 1433 open to anywhere. You may have some human errors, and it's time consuming because it works well for one application. Now imagine you have hundreds of applications. You have to repeat the same step 100 times. So that's not the best way of doing things. So how you can automate it? You can automate it by using AWS CloudFormation templates. So with CloudFormation, you can have a standard template and you can use that template to provision the required infrastructure each and every time. So all the resources can be converted in the form of code. And when you run that code, underlying infrastructure will be provisioned. So we'll look into this CloudFormation part here. So with CloudFormation, you have code infrastructure. You can code your infrastructure from scratch with AWS CloudFormation template. And the supported language here is JSON YAML, right? So you can write a template based on JSON for provisioning AWS resources. Then you can store that template in Amazon S3 bucket. Your template code and everything would be uploaded to S3 bucket. Um, when required, you can run this CloudFormation template. And by the way, you can run this template in not only within the region, but in any other region also. So let's say you are building a disaster recovery site for an application, you can use a single CloudFormation template and you can run it and your DR infrastructure can be provisioned. So you can use CloudFormation via the browser console or the command line tool, or you can make an API request to create a stack based on your template code. And in output, you can see what are the AWS resources that has been provisioned, and you can drill down to each and every steps to see what happened uh, at a given point of time. So this really helps us in automating the infrastructure provisioning. Now we'll talk about management. When you have to manage your Windows instances or when you have to manage your resources in AWS, what are the options here? So we can manage it using AWS System Manager. And with System Manager, you have a component called run command where you can remotely execute any command on any of your EC2 instance, Windows EC2 instance. So some of the common tasks which an administrator do is like resetting an administrator password, restarting services, group policy update, configuring Windows Update, VSS snapshot, and lot and many more. There are tons of tasks, right? And when you have to do those tasks, you don't want to log into each virtual machine separately and do all those activity. That's an old way of doing things. You want to automate as much as you want to automate things as much as possible, right? So you can use a run command in this case. So using run command, you can select your target, which will be pool of EC2 instances, and you can let's say if you have to restart services, you can select your EC2 targets, EC2 instances, and you can execute a restart service without RDP, without taking an RDP session into the EC2 instance, which is really cool. and run command will be executed with local admin permissions. So in this case, you just have to have a systems manager agent running on your EC2 instance, and then you can remotely run a PowerShell command. You can also have a session manager, which we will look into upcoming slide, to manage your EC2 instance configuration. But first, let's look into run command. So with run command, you can execute PowerShell command remotely. So run command generally comes in a document. It's non-interactive, meaning it's in the form of code, right? And it's good for bulk administrative changes. So if you have to make change into multiple EC2 instance, you can very well use run commands. So one example could be, pushing metrics, memory utilization metrics, disk utilization metrics to CloudWatch. You have, let's say, 700 EC2 instance. You don't want to execute CloudWatch log collection script manually to all those 700 instance. You can use run commands to do this bulk operation. The thing with Session Manager, it's interactive, so you can see everything from the GUI. It's good for full interactive access, and it supports port forwarding also. Uh, Another example could be patch management, patching your Windows instances in cloud. So you have a fleet of EC2 instance which is outdated, which doesn't have a recent patch. So what you'll do, you can use AWS Systems Manager Patch Manager service to patch your EC2 instances. And with Patch Manager, you have control over patching policies. You can say that you just want to install critical patches, you just want to install security related updates to EC2 instance. You can create a baseline policy for patch management, and you can also control the action. So let's say you can define that go ahead and install Windows Update, but do not reboot my machine. So you will have that control as well. So it's an interesting service when it comes to patch management. System Manager really makes our life easy by providing patch manager services. You can also define maintenance window. With maintenance window, I mean, you can define a time slot that okay, patching operation should run within that time period. It should not go beyond that time period, right? So AWS will ensure that all the patch related activity happens within the maintenance window that we specify. It's another cool example for managing administration for Windows workload. All right. So with System Manager, Patch Manager, you can scan instances for missing patches. You can apply missing patches individually or to bulk instances using tags. So in AWS, you have tags. You can define tags for to apply certain policies, patch-related policies, and you can create baselines that include rules for auto approval patches. So if let's say you want to install security updates as soon as possible, you can create a baseline policy for that. Whereas maintenance window, create a recurring schedule to perform administrative tasks. So this ensures that all the patch related activities are performed within the given time frame. Maintenance window can integrate with your run command. It can integrate with your automation, Lambda, and with AWS step functions also. Will That's for administration, and it's for that's for monitoring. But now we'll that's for administration basically of Microsoft workload. But now we'll talk about monitoring your Microsoft workload. So administrator, as part of operations, you also need to monitor your resources, monitor your EC2 instance for CPU, memory, disk, network utilization, service availability, server availability. You'll have some defined SLA for your application, so you have to make sure you meet those SLAs. So what are the tools available uh, from AWS? So the primary tool which you will be using is CloudWatch. So you can see the metrics related to CPU, memory utilization, network utilization on CloudWatch. And let's say if an application or if a service is unavailable and it is detected by CloudWatch, so you can set an alert which sends a notification to administrator, or you can set an automated action that, okay, let's say if service is unavailable, go ahead and restart the service via Lambda function. So these actions can be performed. So it's very interesting, and the primary tool which you'll use for monitoring your Microsoft workload is Amazon CloudWatch. You also have requirements basically as part of operation. You also have requirement to centralize, log storage. So you'll have IS log, you'll have Windows event log, you'll have SQL logs, you'll have cluster related logs, and if you are having a third party application, you also want to aggregate those logs into a centralized location, and basically look into those logs in a single dashboard. So CloudWatch log agents can really help in this case, and your target can be your EC2 instances. Uh, all you need to do is to install CloudWatch log agents onto your EC2 instances, and this will push the logs to uh, Amazon CloudWatch. So you'll have all sort of logs going into CloudWatch, and we'll see in the upcoming slide how you can do intelligent log analysis once you have centralized logs. So So how would I analyze? Let's say I have aggregated all logs from my resources. I have IS web IS app, MySQL logs, Active Directory logs. Everything is centralized, is centrally stored in CloudWatch. Now, how would I analyze? So there's a service called CloudWatch Log Insight. It's an interactive search. You can even run custom queries, and you can run queries on real-time data, just and you can filter out the results. So and if required, you can again integrate this service with QuickSight to have a dashboard built for you, and you can see logs in a centralized location, and you can build the dashboard also. So CloudWatch Log Insight really helps us in filtering out result. So let's say if you have error registered in one of the log entry, you can filter out those error logs, and you can drill down into each and every messages, each and every event to see what happened at what time. So it's a really interesting tool, uh, and it really helps administrator to visualize all the logs centrally. Another activity which you will perform as an administrator is to keep an inventory, right? You want to generate a report where you have to present a report to the management saying that this is the inventory, these are the list of application that is running on EC2 instance. So you can do that using Systems Manager Inventory module. So with Systems Manager Inventory, you can collect operating system versions and patch level details, what softwares are installed in your EC2 instance. You can also get details related to software installation, anything related to application configuration, license, file, network configuration, even registry related details can be captured using Systems Manager Inventory module. And the target in this case would be, of course, EC2 instance, because uh, you are capturing all the details from your virtual machine running on AWS. So target would be EC2 instance. Right. At times, from an administrator perspective, you also want to manage the configuration of your EC2 instance, right? And you want to push that configuration centrally. So you want to define, RDP access rules, firewall rules. You want to enforce application settings. You have some bootstrap script, and you want to run those bootstrap script for when the instance boots up, right? You want to automate Windows instances to join Active Directory domain. So you want to automate those actions, and you want to centrally define a configuration, and you want to push that configuration to a fleet of EC2 instance. One way to do it is again manually, which I will not recommend. But if you have to do those bulk operation, very handy services for you would be Systems Manager, State Manager. Using the State Manager, you can define your ideal state for your Windows machine, and once the policy is defined, once the document is written, you can select a set of EC2 instance, and you can push those configuration to those selected EC2 machines. So it really helps us. Now this is about EC2 instance. Now what about other AWS resources? If I have to manage my configuration for other AWS services, let's say system manager inventory service itself, or an RDS instance which is running SQL Server, how would I define or how would I manage configuration changes to all those resources? Now, you can use config service in this case. In using config service, you can define your configuration requirement in the form of rules, and you can make sure that these rules are audited, and you can ensure your that you meet your audit and compliance requirement, right? So common task here would be discover configuration changes. If anything happens, if any changes happen in the configuration, like who did what at what time, all those details can be captured using config. Change management, continuous audit and compliance, compliance as code, security analysis, and troubleshooting and remediating non-compliance requirement. For all these tasks and activities for other AWS resources, you can use AWS config. So when you have, let's say, an object or a user who connect to an RDS instance and who's not authorized to connect to RDS instance, you can set up a config rule, and you'll get an alert based on that task. Uh, so how would you manage compliance with System Manager and AWS config together? We'll see in this slide. So here on the left hand side, you'll have fleet of EC2 instances, and you will use System Manager automation. You can also use AWS System Manager inventory service, which will collect all the inventory of your EC2 instances, right? You can also integrate Systems Manager inventory with your on-prem resources. If you have installed Systems Manager agent, then yes, you can integrate with your on-prem resources also. So once inventory is collected, you can push those inventory and all the related uh, files to AWS config. And in config, you can define your configuration rules. So you can define your governance and compliance requirement, and then you can do a discovery phase. With discovery phase, you'll have integration with S3 bucket. You can also send a notification for anything. If any compliance breach or if any governance violation happen, you can set an alert. So the bottom line here is you can have not only you can have AWS resources hosted in AWS like EC2 instance, but you can also integrate Systems Manager with your on-prem resources also. And this can centrally integrate with AWS config service to make sure that your governance and compliance requirement are met, right? Now we are heading to the last uh, phase of our operation cycle, which is fine tuning the Microsoft workload in cloud. So you have defined now you have defined the whole cycle of operation. You have monitoring in place. You have your governance and compliance requirement in place. Now, how would you fine tune the workload? So basically, the tools which you'll use is AWS Trusted Advisor, and what it does, it analyzes your workload in terms of cost, performance, security, fault tolerance, storage optimization, and service limit. So these are the pillars uh, which you can which you can fine tune basically. And the target again would be your can be your EC2 instance, and can be other AWS resources, which we'll see in the upcoming slide. But uh, with Trusted Advisor, you can centrally visualize your cost, performance, and security, fault tolerance state in a one dashboard. So it will integrate very well with Amazon EC2 instance. With Trusted Advisor, you can do core checks, and recommendations are available to all AWS customers. So it will give you recommendation that, let's say, if you have a port open to anywhere, this will be highlighted this will be picked and highlighted by Trusted Advisor. If you are reaching an AWS service limit, Let's say for VPN connection, the soft limit is 5. So if you're hitting that limit, or if you're nearby that limit, you you can centrally view that in Trusted Advisor dashboard. Similarly, if anything related to performance degradation or anything related uh, to fault tolerance is detected by Trusted Advisor, you can again view that centrally in Trusted Advisor dashboard. Cost optimization recommendation can be provided by Trusted Advisor. So if you have a EC2 instance which you are not utilizing or which is underutilized, uh, Trusted Advisor can pick that and it can show the information in the dashboard. So it's a very handy services. Now we will summarize our operation lifecycle. Remember, we have that slide in the beginning of the operation when we're discussing the operation cycle. Now we will revisit this slide just to see how each service fit in. So with infrastructure provisioning, we have cloud formation, where you can define your infrastructure in the form of code, and you can rerun that template to provision the whole infrastructure automatically. For configuration management, you have systems manager where you can define your required configuration inside the system manager, uh, and then those configuration can be pushed to a set of EC2 instances. For monitoring and performance requirement, you have CloudWatch, you have CloudWatch Log Insight. You can centrally monitor the performance of your Microsoft workload. For governance and compliance, you have systems manager, you have AWS config, which we visited. And in addition, now you have license manager also. So you can centrally track your Microsoft licenses, and you can define a hard rule that, okay, if we need, the license should not go beyond, let's say, 8 core. So you can define those rules in license manager. But we have seen how the governance and compliance uh, process in AWS config and systems manager. Now with resource utilization, in the end, we checked about Trusted Advisor, how you can optimize your resource. So with Trusted Advisor, you'll get the recommendation directly from AWS for the pillars which we discussed, like cost, performance, fault tolerance, security. So those recommendation can be viewed centrally, and you can take steps to implement the recommendations. So this completes our operation cycle for Microsoft Workload. Now, any question, guys? So if you have any questions, you can please you can reach out to me, and I'll I'll answer. I'll get back to you with the answer.
Thanks, Rahil. Thanks for such an insightful session. Thank you guys for attending.
You're welcome.
Thanks, Rahil.
All
Bye.
right, guys.